unconventional machining process. Then we will try to understand why we want to study about unconventional machining process, what is its use, understand about its characteristics, and process. Okay, that is what the topic what we are going to discuss today. And if you see unconventional machining process, uh, you will have this is also called as non-traditional machining process. Previously in the books it is given like that, but nowadays no people use this technique frequently in even industries. So these nowadays no, they are not called as unconventional machining process or non-traditional machining process. Now they are called as advanced machining process. Okay, just before going to discuss the actual process, we will call hereafter we will call this as advanced machining process. Okay, this is advanced machining process because previously no, this was unconventional, but nowadays no, people are using this process for many products. Okay, so nowadays they are calling it as advanced machining process, right? So when you see unconventional machining process, you can classify unconventional process based on several factors. One is based on energy, right? Energy, mechanical energy. So if the energy supplied to do machining is mechanical based, then it is called mechanical energy based process. Under that category you will find abrasive jet machining. This is called abrasive jet machining, and water jet machining, and abrasive water jet. Okay, this is the combination of these two. Okay, abrasive jet and water jet. Okay, so these three, whatever red color, right, highlighted in red, we will see today, right? We will discuss that. And if you need anything about the other process, I will give a hint, or I can also share my PPT so that you can just go through it, and you can, if you have still, if you have any doubt, and you can anytime you can just mail me, I will reply to you, right? Okay, so this is mechanical based process. If you see chemical, electrochemical, we are going to see only electrochemical machining. Okay, we are not going to, the principle is same for electrochemical grinding and drilling. The purpose is different. Okay, here the purpose is different. Some n is missing here. Okay, so this is electrochemical. Under electrochemical we are going to see one process. Okay, and electrothermal or electrical based process, you know, in that case we are going to see electric discharge machining. Okay, uh, and thermal process, we are going to discuss about laser beam machining. Okay, we are going to see under each category, we are going to see one of the process, and the principle is same. Basically, if you see mechanical energy based process, the main mechanism of material removal, because that I will come to that. Before coming to the mechanism of material, we will try to understand what is conventional machining. So suppose if you have a scrap material like this, will you use it? We cannot use, right? Some steel scrap of this, we cannot use it, right? Because this will not fit into any application. Okay, we need some component which we can use it. Okay, a scrap which some irregular geometry is not useful. Okay, so what we can do? Suppose this can be no, uh, converted into a product. Okay, suppose if you take a bolt, just this is your bolt. So what you are doing? First, no, you will have to remove the excess material, right? Whatever material you have here, I am hatching it now. So that you have to remove this area, so that you will get this. Okay, this area, right? I will put opposite sketch hatch, right? Put this, right? You will get, finally you will get, and finally you make a thread here at the this area, right? You have to make a thread so that it will be a useful product. Okay, this is a useful product. Okay, the bolt is a useful product. So you are adding a value, okay, by one of the manufacturing process. Manufacturing itself, the definition is value addition process. It's a value addition process. If you have a scrap, nobody will use it. So suppose if you convert that scrap into a bolt, that will be a useful product. Okay, so you are adding a value, because if you have a scrap, you see, you can nobody will buy it. Okay, so it has no value or little value. So only when you convert this into bolt, then it will have a value. What you are doing here, manufacturing, you have many different processes are available. I hope Professor has already discussed about that. Machining is one of the process where you just remove excess material, right, to get a particular shape. And this whatever material you removed here is, it will be in the form of chips. Okay, this is the chips. They will be waste, and it is a scrap. You can still recycle it, but it is a waste. Okay, so here what we have. Wait a minute. I will just clear my screen so that some animation you can see. So you see here this rod, right? You have a tool here. This is a sharp tool in the form of wedge, and the second point what it is given is sufficiently harder than your workpiece. Okay, the tool must be. So this is your job. This is your work, and this is your tool. So you have some relative motion, right? This is rotating in this direction. You just slightly move a tool and just touch your workpiece. When you have a contact, right, no, there will be some relative motion. Because of the relative motion, the material, right, it will undergo plastic deformation. Finally, it will exceeds it UTS, ultimate tensile strength. Then your material will know. It will be, there will be shearing action. Okay, you just understand. There is a shearing action. Okay, there will be shearing action. Because of the shearing action, lot of material, right, which is coming out, right? These are the chips which are coming out, right? That is a waste. Okay, so you need to have a tool which will have a wedge shape, sufficiently harder than your workpiece. This is a base rule or thumb rule for any machining process. Okay, for any machining process, your tool must be harder than your workpiece. Okay, and other thing, you have to hold your tool and you have to hold your workpiece rigidly. These are all, no, you already studied, right? Then they are giving some depth here. They are giving some depth so that the material will be removed. Okay, this is the relative motion between these two. Okay, always you have a relative motion. Okay, that is what it is given here, and you have some material which will be.
ஹலோ ஏகேஎல், நீங்க எதுவும் பேசுறீங்களா? வாய்ஸ் ஒன்னும் கேட்கல. ஏகேஎல் எதுவும் பேசிட்டு இருக்கீங்களா? ஏகேஎல், உங்க மைக்கை அன்மியூட் பண்ணுங்க. ஹலோ ஏகேஎல்.
See, am I audible now?
Yeah, it's okay now.
I don't know how it was unmuted, right? Sorry.
Sometime it happens.
Yeah. Sorry.
No issues.
This figure I explained now. That time my voice was there, no? First figure, this one. Hello. இது பேசும்போது கேட்டுச்சா? Okay. Oh, okay, no problem. Okay.
Proceed with second figure.
Yeah, right. This is your tool, and this is your workpiece. Wait a minute. This is your workpiece. Okay, this chip, no, you have plastic deformation here. So it is deforming like this, no, it is going. This is chip. This is your chip. Okay, this is a close-up view of how your material is getting deformed. So the problem here is, no, you have always tool chip interface. You have tool with work interface. Okay, so always you will have a friction, and the forces acting on your tool is enormous, and lot of tool wear will be there, right? This is one of the problem in conventional machining. This is you all know this is a drilling operation. And what is this? This is end milling. This is your end milling process. Okay, this is your grinding. Okay, this is grinding, cylindrical grinding, and this is shaping. Okay, this is a principle of shaping process. Okay, this is some of the conventional machining process which we have wide variety of processes. Uh, the problem here, if the workpiece hardness is increased, your cutting speed will be decreased. Okay, you have to use lower cutting speed if your hardness is so high, and that causes your productivity, to the lower level. Okay, that is one of the problem. And nowadays the material development, no, the material scientists, they are all developing materials. Titanium alloys. No, titanium alloys was there for longer time, long back they found. But recent days, if you want to enhance strength like creep, or for some properties like fatigue, okay, they use a lot of steels like some steel with some matrix and some reinforcement, nano reinforcement like ODS alloys. Okay, those are every day now they are developing alloys for particular application, high temperature application, especially high temperature applications. If they develop materials, then fabricating component out of which is also difficult because of the increase in the strength value or hardness value. That is one of the problem we usually have. So when the workpiece hardness is increased, your tool material hardness is also should be increased, because I told you tool material hardness must be harder than your workpiece, right? It's higher, it should be high enough to remove material from the workpiece, right? And as I told you, always you have frictional interface between your tool and the chip and tool and the workpiece. Always you have cutting forces. I hope you studied the cutting forces X, Y, Z. Okay, that requires superior quality of tools. These are some of the limitations of conventional uh, machining. And if you see engineering materials, no, these two, right, the composites and ceramics, they are gaining more popularity. Okay, definitely it has its own advantage over the metals and alloys. To machine metal and alloys, we can use ceramic tools. Usually, when you carbide tips, carbide tools they use. Sometimes, CBN, cubic boron nitride, some kind of coating also. Sometimes tool with some kind of coating they use for metals and alloy, especially stainless steel is difficult to machine. We will discuss that. Nickel alloy is difficult to machine by conversion welding. Even if you want to make a hole in stainless steel or nickel alloy, it's so difficult. Now we'll discuss why it is so. Uh, that is possible by unconventional machining. That is why we want to move towards unconventional machining for some purpose. Okay, we will try to understand. But for machining ceramic itself, which cutting tools we have to use? We don't have cutting tool. The cutting tool is not available, to machine ceramic. Okay, that is one of the problem we are facing in conventional machining. So definitely we need to go for unconventional machining. Okay, as I told, present day demand, right? Every day the demand is increasing. Initially, the boilers, they operated at 500 degree, then they moved to 550. Nowadays, no, they are looking for 750. Okay, there are ultra supercritical boilers. They want to, have this temperature. Okay, so the material what we are using there, no, it requires high temperature strength and other properties. So the demand for the materials, they keeps on increasing, like aerospace, machine, whatever it may be. So engineering materials having superior property, they are developing each and every day. Material scientists, they will develop materials, so that will lead to ultra strength and also hardness. Okay, for example, one material which is very popular in automotive no sector is DP steel, dual phase steel. Okay, that steel will have around the strength of 1200 megapascal. You just imagine this strength. Okay, so if you want to do some machining in this, it's somewhat difficult, because here it is not a problem for automotive because it is a steel sheet. Okay, there is no problem. There is no problem in it. But if you have thick sections, then it is a difficult task. Okay, uh, so high temperature resistance, but it is difficult to machine by conventional machining methods. That is a problem. Okay, so how to solve the problem? If the workpiece hardness is too high, the tool material hardness, we don't have the material. Okay, what we can do? you cannot use conventional machining process. This is one reason why we want to go for unconventional machining. Okay, workpiece hardness doesn't matter. Okay, in case in any of the unconventional machining, workpiece hardness, it doesn't matter, because the interaction between the tool and the workpiece, no, it is restricted. There is no such interaction. So naturally, the workpiece harness is independent of the tool. Okay, that is the advantage in case of unconventional machining. This is one of the reason why we want to uh, move towards. Sorry, some problem with my PPT. I'll just open it again. Uh, this happens every time as a problem. Okay, wait, please wait a minute. I'll start wherever I stop. Okay. Some of the application I just skip this. I'll straight away. Yeah, I'll come to this. Are you able to see this? These points. Stainless steel is difficult to machine by conventional machining process.
Yeah. It's
Yeah,
visible.
yeah. So if we answer for these questions, then we will understand why we want to use unconventional machining. What is the necessity for any of the unconventional machining, whatever listed in the first slide. Okay. Suppose first one is what is the question? The question is stainless steel is difficult to machine by conventional machining process. Why? Okay, this is the first question. Suppose I have a stainless steel plate. See, we all know stainless steel. Everybody knows stainless steel. Only stainless steel. We have different grades of stainless steel, like austenitic stainless steel, ferritic stainless steel, martensic stainless steel, precipitation hardened stainless steel, and duplex stainless steel. Okay, these 5 stainless steels are very popular. All of these are in different areas, or different areas of applications. But whatever we are using, they are all austenitic stainless steel. Okay, they are austenitic stainless steel. Even austenitic stainless steel or duplex stainless steel, if I want to make a hole, okay, suppose I have a plate of 200 mm and 100 mm width. Okay, I want to make a hole at the center. Okay, for a particular, suppose the depth of this hole, no, it's around 50 mm. It's very difficult, because the stainless steel, no, one of the property of stainless steel is stain hardening. Okay, when you deform the material will undergo hardening. Okay, that is what stain hardening is one of the property. This problem is always there in stainless steel. Okay, so drill bits whatever you have with you will not work. Okay, so what happens, immediately the tool wear will be, lot of wear will be there, and the flute, no, the cutting edges will be lost. When you do even one after one drill, no, your cutting tool will be lost. Okay, your cutting edge will be lost, and you can further, you cannot use that same drill bit again. Okay, that is one of the problem. Even sometimes, no, without drilling halfway, if after passing to the halfway, halfway of the hole, the problem, no, the tool will undergo wear. Okay, that is a problem in stainless steel, mainly due to stain hardening. Then how can I make a hole in that? So there comes unconventional machining process. This is one if answer why we want to use unconventional machining. The second question is, if you want to fabricate a tool made of tungsten alloy with complex features. Okay, complex features in the sense, suppose if your tungsten alloy, take a tungsten alloy. Okay, you have a curvature kind of cavity. I want to cut this cavity in a tungsten alloy. Okay, I hope you all know tungsten. The melting point is around 3000 degrees centigrade approximately. Okay, so it is very hard also. Okay, it's very hard. Okay, so you cannot do by conventional machining process, except one process. Only one process you can do some machining is grinding. Okay, you can apply grinding, but still no, approaching some complex geometry as well as approaching some inaccessible areas is always difficult for grinding process, because you will be using a wheel. I hope you studied grinding. uh, so it's very difficult. Okay, that is why if you want to machine some kind of hole, suppose small hole in a tungsten alloy, then you have to go for unconventional machining process. Okay, this is one of the reason why we want to go for unconventional machining. The other thing, the next point is, a customer wants to have 0.4 mm hole with L by D ratio of 15. Okay, that your ratio is also your diameter is very small, but you are going for a longer hole. Okay, the length is somewhat higher. Okay, your diameter is less. Say for example 0.4 mm. It's very very difficult because we don't have drill bits for that. Getting 0.4 mm, right? Now 400 microns, right? It's very difficult. Okay, can we use a drilling machine for this task? It is not possible because even if you get a drill bit for this size, holding it no without vibration, the drilling machine is always difficult. Okay, so naturally you cannot use for such a small hole. And also this ratio, just imagine this ratio, suppose if it is 100, it's always difficult. That we call it as deep drilling. Okay, deep drilling is one of the technique where we used to hole very small holes for a longer length. Okay, so it is not possible. Okay, so we have to go for some unconventional machining. We cannot use conventional machining. This is one thing you have to remember. The next one, a component with long and thin section need to be polished for an application. Can you use grinding for this purpose? Okay. What is the problem? Because see, you have a piece, work piece of this. Right. I'll just draw it. You have this one. Wait a minute. I just draw it. See this thickness. Okay, here a very thin thickness. Suppose if this is 50 mm, this thickness is only 5 mm. Suppose, see diagram now is not dimension. Okay, please just its approximation. Suppose if it is 5 mm, right? So can you use grinding? Grinding, if you want to do grinding this kind of jobs, you have to fix it. Okay, fixing is one of the problem. Even if you fix it, there will be a lot of distortion. Okay, there will be a lot of distortion. So naturally, grinding for thin sections. Suppose you consider only 2 mm, 2 mm thick. If you go for grinding, then it is difficult. Okay, this is also one of the problem. Okay, so here also we need to go for unconventional machining, right? Right. Yeah. The last point is a groove of 7.5 mm into 7.5 mm and depth of 50 mm. Okay. Is very difficult. See, it is on, you just check, it is on magnesium alloy. So magnesium alloy machining is not so difficult, but it is very very easy. Magnesium alloy, you have other problems, though you have other problems. Machining is so easy. And finishing also it will be excellent if you do conventional machining. But the problem comes here is a square groove. Okay, square groove is the problem. That too, you see the dimension. The dimension is 7.5 into 7.5. Okay. Do you have any process for this? Any idea, students? You can answer. Any idea for this? Unfortunately I have written that. I started writing, but I just. Any idea if you want to make a square groove of 7.5 mm into 7.5 into 50, it is still possible in conventional machining. Only one process is available. Any idea about this? See, you can also be interactive so that I can move. No, it will not be boring because I will another 30 to 40 minutes. I will just move with my presentation. If you have any answer, you can just let me know so that we will just move it in interactive mode. Okay. Any idea about that? Okay. If you have any doubt about these points, am I audible? Hello.
Yeah, audible. No issues.
Okay. I'm not getting any answer. That is why. Okay.
No. That you will not get all the time answer.
No. See. Okay. No issue. See. Feel free. Students, you can just see.
Guys
Feel
are
free.
really strong enough, but they are not bold enough.
No. See, don't worry. See, see, the idea of this presentation is to share something on the basics. Now, this is not, no, they are not advanced topics. Just to understand, no, why we want to use unconventional machining, because you already studied see lathe machine and turning operation, drilling operation, grinding operation, okay, some kind of milling operations. Okay, you already discussed those machining processes. We are going to discuss something different. Why we want to
உங்க ஆடியோ கட் ஆயிடுச்சு. ஏகேஎல் உங்க ஆடியோ கட் ஆயிடுச்சு.
see? I am not muting myself. Somebody is muting me.
ராஜநாராயணன்,
I am continuously present. See, make others as attendees. This problem I will face because I used to do only. I will just make them attendee. I am not muting myself. I am not muting myself. Somebody is muting me. Okay. Okay, no problem, no issue. Now I am audible, isn't it? Yeah. Because no, see, I am checking with my mic, but it is working. Just somebody is muting me.
Please
Okay.
proceed.
Okay. Yeah. Right. Right. See, I will just give you the answer. See, have you heard this term, broaching? Only if you say something, I can continue. Otherwise, I can leave this and I will move forward. Right? Broaching is still possible. If you have a square broach, you can do that. This one, okay, that is possible. So mechanical based process. You have abrasive jet machining, water jet machining. What we are seeing here is a water jet machining. This is EDM, electric discharge machining. Okay. This is actually plasma. This is plasma cutting. Okay. And some chemical, electrochemical base is also there. And these are some of the advanced finishing processes also there. I am not going to touch up those aspects because they are all other than this. These topics, no, they come under nano finishing. Okay, they are all nano finishing process. You don't worry about that. You just at least at the end of this presentation, I would like to hear from you what is meant by impact force and how it differs from gradual loading. These are the general question. I'm just this will have some idea we will have on that. What is impact force and how it differs from gradual loading? Okay, you just imagine tensile testing and impact test. I hope you all used those machines, right? Tensile testing machine as well as impact testing machine, right? And we are going to see sandblasting and abrasive jet. You don't worry about now. You just note down this question. We will discuss at the later stage. Okay. And one more question. See what we are going to do. Why abrasive cannot be reused? Okay. These questions you just note down. You can put it when I at the end you can just put it, right? So first process is abrasive jet. As the name suggests, you will be having a jet of abrasives. What is abrasive? Abrasives are they are all ceramic particles, right? Like silicon carbide, boron carbide. Okay, some kind of glass beads. Okay, these are abrasive particles. What we are going to use. What we will do? We have a plate. Okay, you have a nozzle. Okay, so you above the nozzle you have a mixing chamber. We will see the figure. Before that I will just introduce you. You have a compressor, air compressor. Okay, you will get compressed air, and you have a hopper. One side you will add abrasive. So this is your mixing chamber. Okay, this is your mixing chamber. You will get air from compressor. Mixing chamber, you will have two inputs. One input is compressed air. Okay, one input is compressed air. Other input is abrasives. Okay, abrasives is nothing but a hard ceramic particle. Okay, like silicon carbide, boronite, garnet. Okay, widely used is garnet. Okay, these are some of the abrasives. You will be mixing both abrasives with the air. Okay, you will be mixing abrasive with the air. Uh, how much you will mix? That is called mixing ratio. Okay, you just note down these points. When we discuss about the process, you can just understand it. Okay, before going to the actual process, you just understand this terminology. Okay, you have a mixing chamber. You have a compressor to supply air. Both will be mixed thoroughly. It will be pressurized to reach the nozzle, and you have a nozzle. I will just now I am telling you the component of the system. Okay, we are going to see a process called abrasive jet machining. In that, we have a compressor to supply air. Okay, just a gas. Okay, and we have a abrasive hopper. Okay, you have abrasive tank, and from which you have uh, abrasive hopper through which you will supply the abrasive. Okay, in the mixing chamber, both will be mixed, and because now it is pressurized, you have pressurized air, so that will be carried to your nozzle. Okay, whatever the air I'm talking here is called carrier gas. I'm introducing this term now, carrier gas. Okay, so what I introduced now, one is abrasive, other one is compressor. You have a mixing chamber where both will be getting mixed. It will be pressurized and it will be carried to this nozzle, where whatever the pressurized energy, that will be converted into kinetic energy, and all the particle will come out through the nozzle and it will hit your workpiece. Okay, this is your basic principle. With the figure, I will try to understand. You don't worry. See, a lot of theory is there in my slide. I will just share it to the professor. You just get it from him. Uh, I will not read everything. I will just directly go to the picture and try to explain it. Okay. This is a jet of abrasives, and it's continuously, it is hitting your workpiece, and it will remove some material. Okay, how it removes, that I will come to that. Okay, before that, this is what I told you. You have a gas supply. Okay, it's nothing but it may be sometimes air, depending upon the material, right? What material you are going to do some kind of finishing machining operation. It may be air, it may be nitrogen. Okay, it may be nitrogen, or sometimes other gases also being used, but these two are popular. But air is very cheap and it's easily available, so you just add a compressor here, air compressor. Okay, you just add a air compressor. You can control the pressure. Jet will be passed through a filter. Why we are using a filter here? Just unwanted element, or no, just if you have a moisture content there, you just filter it. You have a pressure gauge to monitor the pressure whatever you are inputting, and you have a regulator here to control the pressure flow, so that will be mixed here. So this is your mixing chamber. Okay, your mixing chamber, where you will just add abrasive, right? You have abrasive now, which I already added, and you have a vibrator source which will vibrate this setup, so that no the air will carry, or this gas will carry your the abrasive particle, and it will go through these tubes, and finally it will reach the nozzle. Up to this, we have pressure energy. Okay, we have pressure energy. So once it reaches the nozzle, I hope you all studied, fluid mechanics, orifice. Okay, so the pressure energy here is converted into kinetic energy. Okay, kinetic energy, and you will get a jet of abrasive particle. Okay, so these particle will hit the workpiece, and it will remove material. We don't worry about now how it will remove material. That I will come to that. Okay, before that, we will try to understand the process. Okay, this is another figure just to refresh again. You have a gas supply. Okay, if it is a nitrogen, you look like this. Okay, if it is a compressor, it will be somewhat different. So you have some valves here, some filters here. Okay, pressure regulator to find out the pressure, powder supply, and mixture. Okay, mixture is nothing but mixing chamber. Okay, different textbook will give different meaning. This is called mixing chamber. Okay, most popular terminology is mixing chamber, and just you will mix it. It will be controlled. This valve, there is a valve here. It's controlled by foot. Okay, so it will go to your the nozzle where it is converted into kinetic energy, it will remove material. Okay, so a lot of dust will be coming. So the particle, no, see, in case of abrasive jet machining, no, they use silicon carbide or boron carbide. No, all the, no, they are all very small particle, no, 50 microns. Okay, very small particles. So once it hits, two things you have to consider. One is the particle size of the abrasive it is hitting, and then the debris, right? Whatever debris, no, some material is removed here. No? They are called debris. See, in case of conventional machining, we call it as chips, right? Here we are calling it as debris. Okay, they are very small. That is why it is called debris, right? So you have to have a hood arrangement, that is a production with sufficient ventilation. Okay, if you want to do this, you cannot do it in a room, because these fine particles, it will affect the person who is doing that operation, right? So this diagram, you just remember, this is another schematic diagram. You have a air compressor. In the previous case, nitrogen. Okay, if it is nitrogen, you have a gas supply like this. Now it is air, it's cheap, and all other processes are there. No, dryer is no, just to remove moisture, filter to foreign particles if any. So that can be removed and it will go to the mixing chamber. You have abrasive feeder here. You just try to understand various components of the system, and then you try to understand the function of each component. Okay, that is important. Okay, then abrasive is mixed with carrier gas. It is mixed here itself, mixing chamber itself. Here it is, one of the figure, it is mentioned as vibratory arrangement. Here they are giving specific name. Okay, electromagnetic shaker is a vibratory arrangement. Okay, so your air is here, it is carrier gas. Carrier, why it is called carrier gas? It is carrying the abrasive. Okay, it is carrying the abrasive. That is why it is called carrier gas. Okay, so it will go to the nozzle, where kinetic energy, you will get very high kinetic energy. So it will have interaction with the workpiece. Now we will try to understand. You just go through it, right? I will not read everything. They are all self-explanatory. I will share my PPT. I hope I already shared it to Professor. You can just get it from him, or otherwise this PPT also I can share with Professor. You can just get it and just go through it, right? Nothing to hide. You see different types of abrasive there, right? You just understand it should be hard, tough, irregular shape, and should have, see, these points are very important if you want to understand the mechanism of abrasive jet machining. This mechanism, this be hard. Okay, you have a particle, right? Some kind of this kind of particle. Okay, you see this particle, it satisfies this condition. Okay, irregular shape. This particle must be very hard. Okay, this particle must be tough in the sense it should not break when it hit the workpiece. Okay, before removing the material from the workpiece, if it fails, or sometimes if it moves along with the carrier gas, this particle may interact. Okay, because it is a gas stream. Okay, your particles are there, so there may be collision between particle to particle. Okay, that there may be this collision may result in failure of this sharp edges. Okay, that is a problem. Okay, so once it hits the workpiece. Okay, suppose I will just draw it. Wait a minute, I'll just clear it. I'll come back. Yeah, see, this is your workpiece surface. Some particle is coming, and it has this sharp edge. It comes here and hit here. Once it hits, this particle, they are all brittle materials. This particle, they mainly these are brittle, especially abrasive. If you want to make a hole in glass, you can do that by abrasive machining. Okay, what happens when this particle, this is one of the particle, I am taking it for just to understand the mechanism. So it come here, it will hit the surface. If it hits suddenly, what happens? There will be a lot of small crack formation, micro crack formation, and it will hit and it will go. This particle will come and remove this workpiece. It will come and hit. There will be crack formation, and this portion alone will be thrown. Okay, is called microchipping. Okay, this mechanism is called microchipping. Okay, this is one mechanism. No? The other mechanism is just you have a surface. You just no. Wait a minute. My pen tab. No. Yeah. Right. It is coming here. It will come here and it will hit here and it will slide. Okay, it will slide. This is called impact erosion. Okay, this mechanism is called impact erosion. Now erosion, see, at a high velocity with a high kinetic energy, it is hitting the surface and it is slightly sliding onto the surface. So there some material removal will be there, like it's a kind of wear. It's called impact erosion. Okay, this is one of the mechanism. This is most of the mechanical based processes like abrasive jet, abrasive water jet, even ultrasonic. There is another process, ultrasonic. All process these two mechanisms. You remember, whenever somebody talks about mechanical based unconventional machining process, you have to remember impact erosion and microchipping. Okay, these two mechanisms are very popular for abrasive. Okay, I will repeat if somebody not able to catch up. Okay, this is your abrasive. Okay, it comes here and it will hit your surface. There will be small crack initially, just initially it will create depending on the surface. So this portion alone, it will be forced to go out. Okay, it will break. No, abruptly it will fail. It will go out. Okay, this is chipping. Okay, uh, once it happened, this sharp edges, no, it may blend. Okay, it may blend because one problem is it interaction with the workpiece. Other problem is interaction between the abrasive itself. This causes you cannot reuse this particle. That is the question I asked. That is mentioned in one of my slide. I asked you to note down. The reason is this collusion causes the abrasive, the sharp edges of the abrasive to be blunt, and also there may be collusion between two abrasive particles or more abrasive particles. Right? That is also other problem. Okay. Uh, okay. Other thing, you just go through it. I will just share only few important points because because of the time limitation, I have to cover many process. So some of the particles of abrasives, you just see some global shape or globular. This is spherical shape. Okay, some small particles depending upon the small particle size. Your abrasive size itself, what we call it as abrasive grinding. If you study grinding, we call it as grain size. Okay, grain size in crystal and grain size in with respect to particle, both are different. uh, Grains are sometimes in grinding we call it as grit size. Okay, grit and grain are both in case of same thing. You have to follow it here. This is your mixing chamber, you don't worry about it. This is some of the system where you have a cutting head. This is called cutting head. Okay, this is your nozzle. Okay, this is your nozzle. We will discuss that. Okay, some of the machined components, you see a very complex component. Okay, see if it is it possible to fabricate through conventional machining? It's still so difficult. Okay, very complex component which a lot of curvature, which you see here. Just see this one. Now complex curvature, you can do that. Okay, gear manufacturing is very very difficult because when you do milling, I hope you all practiced milling. Very difficult. Okay, that is one of the problem. Oh, you are all second year. Okay, still yet to practice it. Okay. Okay. So carrier gas, I told you, air, CO, nitrogen, and the velocity here, you just see how much velocity is that, 500 to 700 meter per second. Pressure is given here, you just go through it. And very important thing you have to remember as far as the abrasive jet is the mass mixing ratio. How much abrasive, okay, you are mixing with carrier gas. Okay, abrasive plus carrier gas. Okay, our mixing ratio is volume of abrasive. Okay, or mass flow rate of mass or something like the volume of abrasive and with respect to the mass flow rate, okay, mass flow rate of air. This term is very important. Okay, what is the since the nozzle, whatever your particle are passed through your nozzle, it passed through your nozzle at a high velocity. Not only your workpiece will be material from the workpiece will be removed, it will also remove some material from the nozzle. So the life of the nozzle is decided by the material what you are using for nozzle. Okay, nozzle, the material. This point is very important. That is why I am insisting this. You will be using tungsten carbide or sapphire. Okay, but sapphire, if you use, the life is somewhat higher. It's around 300 hours. You can go, but tungsten carbide is less. Okay, it is restricted to 50. Okay, 50 hours. Okay. Some parameters with respect to nozzle, mixing chamber, workpiece parameter. We will check it out. Diameter of the nozzle is important, or nozzle type. You just note down. If you have any doubt, I will tell you. The output parameter. These are the input parameter. Okay, you have to control your input parameter. Any process, any manufacturing process, you have some parameters to control, and you have some thing to measure. Okay. Here, what they are measuring? They are measuring machining rate, how fast you are doing, depth of cut. Depth of cut in the sense when you use this velocity, how much depth it is going. That is what it is given, depth of cut. Curve quality and surface roughness. What is curve? When I just see when I have a plate. Okay, I want to cut this. Okay, I want to cut this. Okay, whatever this area, this is called curve. Okay, I want to cut into two pieces. This piece. Okay, wait a minute. I just draw it. I just want to cut this. Okay, if I want to cut, if I put a jet here, it will remove material from this. Now, whatever material is removed here, this is called curve. Okay, this area is curve. Okay, that is called curve quality. Quality in the sense whether the surface roughness is good or bad there in the sides, this side and this side, right? No, they are all same. It is repeating actually. Sorry. See, if you are interested, I will explain this. Otherwise, I will do that. Okay. Can anyone tell me? See, abrasive flow rate. How much? How much abrasive is flowing? Okay. Abrasive is flowing is grams per minute. Abrasive flow rate. Okay. How much grams per minute? Okay, is flowing along with your carrier gas. Okay, the y-axis material removal rate, MRR. Okay, very important two terms. They are very popular. One is MRR, other one is surface roughness. Okay, RA. Okay, these two are important in any machining process. You have to measure that. That is his response, right? These results they got, some of the researchers, they got this. Workpiece is plate glass, and abrasive is aluminum oxide, and the pressure of the carrier gas is 50 grams per centimeter. Okay, this is what, centimeter square. Okay, it's pressure, right? So initially it keeps on increasing, right? It keeps on increasing. So here, whatever may be the grain size. Okay, grain size is nothing but the particle size, abrasive particle size. Okay, particle you have to measure. Okay, particle you have to measure this, measure this in all different direction. You have to measure, take an average. Okay, then it is called grain size. Okay, the abrasive particle size, grit size, or grain size. Okay, so take one curve. Okay, 50 microns. You just it is keep on. When you add more abrasive, there will be a lot of material. Suppose if you have a surface, if the one particle come and hit here, it will be less. Okay, suppose if two particle comes and hit here simultaneously, there will be some increase. Okay, 3 particles, there will be further increase. 6 particle, 5, 6, good, very good. It is keep on increasing because more number of particle is coming and hitting your workpiece, and there will be a lot of material removal. But unfortunately, after this, there will be reduction. What happens if you keep on adding particles, like more particles, instead of all these particles should interact with your workpiece, but that doesn't happen. What happens? These particles will collide each other and it will lose its momentum. Okay, momentum is very important. How much fast your particle is carried by your carrier gas towards your workpiece. Okay, suppose your plate is here, your nozzle is here. The carrier gas is just getting your particles. Okay, if the particle collides with each other, it will not travel further, so it will collide and it will lose its energy. Okay, it will lose its energy and it will go somewhere else. It will not be directed towards your workpiece. That is the problem when you have more number of particles. When it exceeds certain level, around here it is around 10 point something or 10%, so it keep on decreasing because of collusion between particles. Okay, like this you have to understand each and every graph, why it is increasing, why it is decreasing, that you have to understand. Okay, I will repeat this. Initially it is increasing. This is because wait a minute, this is because you have suppose one particle, it will hit two particle. If you hit more number of particles, you have more material will be removed, that is acceptable. But once if you exceed the number of particle exceeds some level, there will be collision between particles instead of collision between the particle and the workpiece. See, our aim is to allow the abrasive particle to interact with the workpiece. That is not happening. That is why it is decreasing. After certain level, it is decreasing. Likewise, the same phenomena here. You just go through it. You just I will skip this. Very important thing I will tell you. You just try to understand some parameters, then it's fine. Standoff distance. How much distance you are placing your nozzle with respect to your workpiece. Your workpiece is now, suppose if it is less than 1 mm, say for example it is here 0.7 to 1 mm, your jet it is very straight. Your jet it is very very straight. When you go beyond 1 mm up to 5 mm, your jet is getting diverged. Okay, slightly diverged. That means my aim is to get only this width. I want to make cut this. Okay, I am my curve width is only this. But unfortunately, when I have a standard distance of 15 mm, my curve width will be this. That too, it will not be straight. It will still go taper. No, it is the tapering will be continue, right? So that is a problem. So you have to control your standoff distance between 0.7 to 1. Okay, that is what the image clearly explains us. You have to control your standoff distance between this. Okay, why? Because here it is straight. When you keep on moving away from your nozzle tip, this is called nozzle tip distance. Okay, also called standoff distance. It is mentioned here. It is also called nozzle standoff distance, nozzle tip distance. Okay, sorry, nozzle tip distance. Right? Yeah. Any doubt about abrasive jet machining? Now it's open for discussion. If you have doubt, see, I'll be happy to clarify it. Then we will move on to water jet. Any doubt? See, around one something around I got data last. I don't know how much are there now. Around 175 crossed. I'll just take it out.
200 plus.
200, 197. Currently 197 are there, but I'm not getting any answer from any one of you, right? Including me, 197. But okay, that's fine. You can just open your mouth, or are you there, or you are all sleeping? Because since I'm not able to see your face, see, I'm not get any feedback. So whether I'm
பவதாரணி இருக்கிறியாமா? லைன்ல இருக்கியா? சாரோட மைக் மியூட் ஆகட்டும், அது ஒன்றும் தப்பு இல்லை, இருங்க. பசங்க சும்மா உட்காந்துருக்கானுங்களே.
பண்றாங்க. See, somebody is muting my mic. நான் mic mute பண்ணல. Actually இந்த மாதிரி மீட்டிங்லாம் better you can just make them attendee. That's problem.
Listening,
okay.
sir.
Yeah. See, listening na Mech second Mech ன்னு இருக்கு. அது பேர் இல்ல, ஒரு பேர் இல்ல. His name is not displaying here.
அவர்தான் அட்மின்.
ஓ ஓகே. செகண்ட் Mech.
தம்பி பவதாரணி இருக்கீங்களா? நித்தி சபரி இருக்கீங்களா? ஜேசன் ஜெபகுமார் இருக்கீங்களா? நீங்க என்ன are you sleeping really or
இல்ல என்ன சொன்னனே தெரியாமலே போயிட்டு இருந்தா இதுக்கு அப்புறம் போக முடியாது. further I will just quickly finish it off.
தம்பி நீங்க ஏதாவது இன்டராக்ட் பண்ணீங்கன்னா மட்டும்தான்ப்பா பேச முடியும். நீங்க எதுவுமே பண்ணாம அமைதியா உட்கார்ந்திருந்தீங்கன்னா சரி.
See, don't worry, right? See, feel free. See, கேள்வி கேட்டு அது வந்து இந்த மாதிரி ஒரு ஓப்பன் ஃபோரத்துல கேள்வி கேட்கறதே ஒரு பெரிய விஷயம் தான். ஓகே, அதுக்கே ஒரு தைரியம் வேணும், தன்னம்பிக்கை வேணும். ஸோ அதனால ஓப்பன் யுவர் மவுத் அண்ட் ஆஸ் சம்திங். உங்களுக்கு எதுவுமே புரியல சார் அப்படின்னு சொன்னா கூட ஒன்றும் வில் நாட் டேக் இட் இன் நெகட்டிவ்லி, ஜஸ்ட் டேக் இட் இன் பாசிட்டிவ் வே. உங்களுக்கு ஹெல்ப் பண்ணுவோம். ஜஸ்ட் அட்லீஸ்ட் என்ன படிக்கணும், எப்படியாவது புரிஞ்சுக்கணும்னா சொல்லுவோம்ல. எதுவுமே சொல்லாம அமைதியாவே இருந்தீங்கன்னா what is the use, இல்லையா? So it is in our syllabus, right? It is not a guest lecture where I can deliver something and I will go. You can forget it. Okay, this is related to your
இருக்கிறதா 5வது யூனிட்ல இருக்கிறதா. இது எக்ஸ்ட்ராவெல்லாம் எதுவும் நடத்தலப்பா. நீங்க என்ன புரிஞ்சுக்கிட்டீங்க?
It is in your syllabus.
என்ன புரியாம இருக்கீங்கன்னு கேளுங்க. சபரி இருக்கே இல்லையாப்பா?
எதுவுமே புரியலனாலும் பரவாயில்ல, இப்ப பதில் சொல்லுவேன். இப்ப கூட நான் பதில் சொல்ல தயாரா இருக்கிறேன்.
சபரி, நித்தி சபரி
ஸ்ட்ரெngth குறைஞ்சிட்டே போகுதுண்ணே. 190 ஆயிடுச்சு இப்போ.
சார் இருக்குங்க சார்.
என்ன புரிஞ்சுக்கிட்டே எல்லாமே?
சார் ஒரு டவுட் இருக்குங்க சார்.
சொல்லுங்க சார், டவுட் கேளுங்க சார். கேளுங்க சார். அதானே கண்டினியூ.
ஆள போட்டா கூப்பிடுவாங்க.
சார் why the abrasive particle not to be reused?
சொன்னேனே, நான் வந்து சொன்னேன் இல்லையா, அப்ரேசிவ் பார்ட்டிகிள் வந்து ஒர்க் பீஸ்ல போய் ஹிட் ஆச்சுன்னா it will have sharp edges, இல்லையா? ரொம்ப ஷார்ப் எட்ஜஸ் இருக்கும். they are all irregular shaped particles. ஸோ அது வந்து ஒர்க் பீஸ்ல போய் ஹிட் ஆச்சுன்னா it will lose its after hitting on the surface, it will lose its sharp edges. Okay, continue. And also there will be collision between particles. ரெண்டு அப்ரேசிவ் இருக்குன்னா கேரியர் கேஸோட ஒரு மீடியத்தோட அது போயிட்டு இருக்கும்போது ஒன்று இடிக்கும், இல்லையா? ஸோ ஒன்று இடிக்கும் போது அதோட ஷார்ப்னஸ் போயிடும். ஷார்ப்னஸ் போயிடுச்சுன்னா அதோட திரும்பி அதை யூஸ் பண்ண முடியாது, இல்லையா? திருப்பி யூஸ் பண்ணால் என்ன ஆகும்? ஃபினிஷிங் எப்படி வரும்? we need to remove material. அது ரிமூவ் பண்ண அடுத்த சைக்கிள் அது ரிமூவ் பண்ணாது, இல்லையா? அண்ட் ஆல்சோ அதர் ப்ராப்ளம் ஒன்று இருக்கு. ஒர்க் பீஸ்ல போய் ஹிட் ஆகுது. இட் இஸ் ஆல்சோ தேர் வில் பி லாட் ஆஃப் ஒர்க் பீஸ் டெப்ரிஸ். அந்த சிப்புன்னு சொல்றது, அங்கே சிப்புன்னு சொல்றதா இங்கே டெப்ரிஸ்ன்னு சொல்றோம். ஓகேவா? சின்னதாக இருக்கிறதால. ஸோ அந்த டெப்ரிஸோட இது கலந்துருச்சு அப்படின்னா தென் அதை செப்பரேட் பண்றதே ஒரு பெரிய ப்ராசஸ், இல்லையா? இது வந்து செகண்ட். ஸ்டில் we can recover some good abrasives, but most widely they will not reuse it because they are cheap.
ஓகே சார்.
இது நான் என் ஸ்லைட்லயே கேட்டிருந்த क्वेश्चनே கேட்டுட்டீங்க. நீங்க உங்களுக்கு புரிஞ்சிருச்சு ஆரம்பத்துல இருந்து?
சரிங்க சார். நான் ஃபர்ஸ்ட் இது தெரியலங்க சார். நீங்க சொன்னீங்க நெட்ல ஆன்லைன்ல தேடி பார்த்துங்க சார்.
ஓகே.
சரி, எதுக்கும் ஒரு டவுட் கூட கிளாரிஃபை பண்ணிக்கலாம்னு சொல்லி கேட்டுங்க சார்.
ஓகே. ரைட். ஓகே, நம்ம யாரே ஒருத்தர் தான் பேசிட்டாரு. ஓகே, நம்ம ப்ரொசீட் பண்ணிடலாம். டைம் போயிட்டு இருக்கு. See, next process is water jet machining, where you will be using a water jet instead of abrasive. You will be using a water jet. I will just quickly go through it because I don't want to waste my time. Directly I will go to the setup. You have a fluid supply tank. It will be go through a mixture and filter. Mixture is nothing but sometimes they will add some stabilizer. Okay, stabilizer is nothing but to get to avoid separation of water molecules when it is being a jet. So when the water molecules they are separated, so that you will not get the force. Okay, if you add stabilizer, what they will do, they will add long chain polymers. Okay, long chain polymers add to this water, so that it will not separate out, or it will not diverge, and it will be focused, and it will be hold it to
ஏகேஎல் மைக் அன்மியூட் பண்ணுங்க. ஏகேஎல் ஏகேஎல் மைக் அன்மியூட் பண்ணுங்க. ஏகேஎல் மைக் உங்க வாய்ஸ் ஒன்னும் கேட்கல. ஓகே.
Hello.
சொல்லுங்க.
Am I audible?
There is no slide.
இல்ல அன்மியூட்டே நான் பண்ணல. அன்மியூட்டே பண்ணல. நான் மியூட்டே பண்ணல.
இது சிஸ்டம் ஃபால்ட்.
அப்படியா?
டீம்ஸ்ல இந்த மாதிரி நிறைய முறை வரும்.
அப்படியா? நான் யூஸ் பண்ணி இத்தனை நாள் யூஸ் பண்றேன். என் கிளாஸ் நடக்கிறது இல்லையே.
நீங்க உங்க சாஃப்ட்வேருக்கு கொஞ்சம் இஷ்யூ இருக்கு. நம்ம நிறைய முறை பார்த்துட்டோம்.
ஓ இல்ல நான் என்ன பண்ணுவேன்னா அட்டெண்டியே போடுவோம். அதனால பிரச்சனை வந்து இல்லை. ஓகே லீவ் இட். பாத்துக்கலாம். நான் டிஸ்கஸ் பண்ணலாம். ஓகே. என்னோட ஸ்லைட் தெரியுதா?
தெரியுது. ஓகே, now it is display.
Now I am able to share the PowerPoint itself. இப்போதான் எப்படி பண்றதுன்னு தெரியல. இப்போ ஷேரே பண்ண முடியுது. PowerPointே பண்ண முடியுது. Okay. So you have a pump here. You all know the pump function of the pump. No, it is to pressurize the fluid, right? Intensifier is intensifier. No, it will increase the pressure. No, to some ratio, right? It will just to some ratio. We'll see that. No, just if you have you have two cylinders. No, so you have a piston arrangement like this. You have another cylinder, some small cylinder. Okay, so this is a big cylinder A. So if it moves here, the fluid, the force acting is same. Okay, force is equal, F1 equal to F2, but the area is different. This area is different, this area is different. Naturally this area is reduced, so your fluid will be compressed here, so it is pressurized. Okay, the purpose of intensifier to pressurize the fluid. Okay, please remember pressure. Purpose of the intensifier is to pressurize the fluid. Okay, we'll have some slides so that we'll understand that. Then it will go to your through the once intensifier intensifies, it will go to your you have accumulator. So you have a control here. You have accumulator. Accumulator is used to maintain the uniform pressure. Okay, maintain the uniform pressure. Okay, this is the purpose of accumulator, or avoid pulsation. Okay, pressure pulsing, if it is there, that you can avoid. Okay, so then it will go to some wall and it will come to the nozzle. Sapphire is there. Sapphire is used here because of the life. As I told in the abrasive, the life is somewhat higher for sapphire when you compare with the tungsten. Then it will pass through the the jet will come out and it will hit your workpiece. Finally it will be collected in the drain. Okay, so here you just understand, if you have a 8-story building, from the top tank, from the top row, from the tank, if it goes, pipe goes to the bottom, ground floor, if you check the pressure there, it will come around 100 bar. Okay, actual 100 bar pressure. There are some calculations for it, you don't worry about it now. It will come around 100 bar. Okay, whereas in water jet machining, it will be around 400 bar, right? 4000 bar. Sorry, I will just write it 4000 bar. So that much pressure is there because of the intensifier. It will intensify to this pressure, and it will go through this wall, and finally it will reach the nozzle. And when it passes through the nozzle, so as I said, no, it is like orifice, right? So naturally the velocity will be increased. So it will go around 1000 meters per second. Please remember this value, that comes under 1 kilometer per second. Okay, that much speed it is coming out. That is used to cut the material. Please remember, this is used to cut only soft materials like aluminium, and also thin and soft materials, not for thick material. That force is not sufficient to remove metallic materials. Thin and soft materials alone you can cut. That also, if suppose aluminium is a thin foils, okay, especially aluminium foils you can cut. Other than that, you cannot use this process for any other material, because it is not sufficient. That even that force, right, if it is 1 kilometer per second and 4000 bar, that is not sufficient, right? So you have to understand the component. See again, this is another diagram where you have a motor which is used to run the pump, and you have a oil here. Another water is there. Two fluids they are using. You just try to understand that. So this thing here is oil. Okay, this tank, this cylinder is oil. This diameter, check the diameter here. Okay, double acting. This is a double acting cylinder. Okay, here it is filled through oil. Okay, this cylinder is this piston is operated by the oil, which is attached to the hydraulic power pack. Okay, this is hydraulic power pack. Okay, the whole setup what we have, this whole setup, no, we call it as water generating circuit. You can note down this water generation circuit. Okay, might be these words are not in my slides, in the words also. This whole term, right? Your hydraulic power pack. Hydraulic power pack is nothing but your motor, pump, and oil tank. This is your tank, oil tank. Okay, you have water tank is separate. Okay, so this oil will move this. I'll just clear it so that it will be clear. Wait a minute, please. Yeah. Your oil will move. Suppose if oil enters here, this piston will move this way. If it moves, there is a water from the other source. There will be some water here. So this cylinder diameter is larger. Okay, this diameter is less. That means smaller area is compressed by larger area. That means you will have higher pressure. Okay, your pressurized fluid will be going through this pipe, and it will also connect. It will have connection with the accumulator to avoid pressure pulsation. Okay, pressure pulsation you can avoid. Okay, constant pressure you have to maintain. Okay, then you have some tubes here to carrying tubes. Okay, very hard tubes. They are all very hard, polymer based hard tubes, which can use, and sometimes very hard steels also they can use for carrying the fluid, right? It's not a problem in water jet machining, but when you combine abrasive, it's a problem there. Water, this is water transmission line. Okay, so what I am trying to mention here is you have three different regimes. One is water generation circuit. What is water generation circuit? You have this hydraulic power pack, you have an intensifier to increase the pressure, you have the accumulator to control the pressure pulsation, you have a water transmission line to carry the fluid. Okay, finally it will go to the nozzle. Okay, so you have to understand the component so that the function you can understand. Okay, other thing you just go through it, the function, intensifier, what is there, you just see some value, whatever I told you, it close to that. It is around 4000 bar, right? So intensifier, they will just go through it. They are all self-explanatory. It is not so difficult to understand. Whatever I told you, it is a continuous flow of high pressure and eliminates pressure fluctuation. Whatever I told, it is there. You just go through it. Nothing else. Okay. Finally, it will go to the cutting head, cutting nozzle. This is some of the setup. See, you have a cutting head here, and the source, some sources here. Power, the liquid source, and some cylinder arrangement is inside, right? It is not outside, it is there in the machine. Okay, this is your cutting head. This is one of the water jet machining. Here also some of the parameters, this also self-explanatory, no need to explain this. Hydraulic, what is the orifice diameter, what is the pressure. If you take abrasive, this is very common. This is not for, this is repeating, this is no for both the process. Okay, abrasive, water jet machining. I will come to that. Okay, I will go to that. Okay. Here also the standoff distance is very important. Jet diameter. These are all the self. They already explained this, right? What are the materials you can cut in using water jet? Leather, vinyl chloride, polyester, Kevlar, graphite. All are no. They are all polymers, right? Wood, no. Water jet. This is for water jet machining. Okay, not for other process. Okay. Some of the examples cutting, or even some vegetables, right? Even some vegetables they can cut for this, right? So now we will come to abrasive water jet. I will rush through the presentation because of the time limitation. If you have any doubt, you stop me. I'll be happy to clarify your doubts, right? I will not read everything. They already I told you the pressure is 4000 bar. Intensifier I explained to you. Only thing is you have to remember nozzle diameter is around 0.2 to 0.4, and the velocity when you try to understand it is 1000 meter per second. That is 1 kilometer per second. Okay, and see whatever I told you, it is mentioned here. Thin sheets foil like aluminium, leather. Just water, pure water or tap water also you can use. Okay. Now we will come to the actual process, abrasive water jet. Okay. Just mix both of these process, right? One process we discussed is abrasive jet. The other process is water jet. See, I want to make it efficient by just combine these two. Okay. I just want to combine these two so that I can cut almost all materials. If I do this, I can cut any of the material, right? So water jet is pure water jet, only water jet. I will just include abrasive, just just allow the abrasive to mix with the water jet, and I will have a abrasive water jet. Now, initially we discussed about abrasive jet, right? And then water jet. Okay. Mechanism is they are different. Okay, abrasive jet, in case what we did, we had we discussed about air, compressed air, which will be mixed with abrasive and it will form a jet and it will be used to remove material. In case of water, we have discussed about water generating circuit, and that is that we have intensifier, we have accumulator or alternator, we also called as alternator. Okay, and thereby we generated water jet. Here it is entirely different. Okay, I am taking the advantage of water jet, I am taking the advantage of abrasive, I am mixing both. Okay, this is very popular nowadays, even some research. Okay, I told you this also, they will add some stabilizer to the water. Okay, why? I mentioned it. Okay, to hinder means to stop fragmentation of water jet. Okay, it should be coherent, right? It's along in a single direction. So if it breaks and it will go, molecules will grow this way, your water jet, it is not what do you call, the velocity will not be there, right? Two methods are there. Entertain is one method, other one is suspended. Okay, we will see that. Okay, see, this is your actual setup. Okay, your water generation circuit is not there actually. Water generation circuit may be in this box. Okay, you have this cutting head. This is your cutting head, which consists of the nozzle and the mixing chamber. Okay, so this is controlled in these three axes, all the X, Y, and Z by a CNC controller. Okay, this is supplied by Omex Corporation, USA. Costly machine. What are the applications? Both these are some of the application. Paint removal. Why we want to paint removal? Big coaches, rail coaches and all. No, It is difficult. No, once some portion is corroded or you used for longer period, then you have, if you want to go for repainting, you have to remove the whatever painting remaining paint available. Then you have to go for that kind of operation is easier. Water cleaning, soft metals, frozen meat. This is no, just go through it. Self-explanatory, right? Some of the materials: steels, titanium, nickel, polymer. You just go through it, right? They are all they are not even stones, right? Granite. I told you, no, any material you can cut using this. Okay, I'll just skip it, right? Wait. Some of the products, I'll just go through it because I want to cover two more processes. I will just quickly go through it. I will tell you this. No, just some of this. Yeah, this is what I told you. No, how you are feeding the abrasives, right? This is through a side feed, so it will have contact with your nozzle. There will be a lot of wear, right? The particle will be separated, and the water is through coming through this. Just the sideways you are adding. That is why, side feed. Okay, central feed, you are just in the jet itself. This is a suspension, right? This is a slurry. Already they added some liquid with that water, and then they are mixing it and they are passing it to the center. This is called center feed. Okay. This is on this principle. I hope you understand. This is your large cylinder. Okay. This is your very, very small cylinder. Suppose if you operate this way, it moves this way, right? If you send the oil here, it will move your piston this way. So that will compress whatever fluid here or whatever water here, and it will be moved towards your accumulator. Okay, this is See, suppose if this is see, for example, wait a minute. This is your formula, right? H into A large. What is this H? Hydraulic, maybe oil. Okay, this is water and small. Okay, because you see that figure here. This is your P water, and here your area is also small. Okay, if you find this, the area ratio, then you will find PW is, say for example, it is given 100 bar is set, area is 40, it will be pressurized to 4000 bar. Okay, you just substitute this. Okay, the ratio, right? The ratio, this ratio is 40 times, and this is 100. pH is 100. Oil pressure is 100. So it comes under 4000 bar. Okay. I'll skip this. Just go through it. This is only for your examination. I just prepared this PPT for my students. No, because if they want to write it in detail, they need not to go back again to the textbook. They can just refer my PPT and they can just write the examination, right? This is your cutting head. Okay, cutting head. You have high pressure water is coming through. You have orifice just to increase the velocity. And at the bottom there is a called focusing tube. Focusing tube is to control your jet to be focused onto your workpiece. Okay, just it's a hollow tube which will not allow to diverge your water jet. This and all you just go through it, right? I will just skip this. I will not how they are adding central feed. This already we discussed. I will not repeat this. This is very important. So see, whatever I will just whatever the jet which is coming out after cutting your sample, still your jet is having enormous energy. Okay, your water jet is is abrasive water jet. Okay, this is abrasive water jet, right? So it cut. Now the sample has been cut, and your the remaining jet will pass through. You have to make the you have to restrict that energy, or you have to reduce the energy. So otherwise, what will happen? You just place another plate. It will cut that plate of backup plate also. It will be cut by the jet. So what we will do? Simple technique is you just have a water tank. Allow the jet to enter into the water and will lose its energy. This is one way. And sometimes you just place some steel ball along with steel ball or tungsten carbide or ceramic balls. So your jet will hit that particle and it will lose its energy. No, this kind of thing is called catcher plate. Okay, this is catcher plate. One aspect is just to have water basin, steel, and other it's called catcher plate. Just place a plate so that it will hit here and lose some energy and it will be diverted. There again you just place a plate. It will diverge it here. There again you just a plate so that it will lose its energy. Okay. I hope it is clear. Catcher plate after after the process, machining process or cutting process, still your jet, abrasive water jet is having the energy, right? So that energy you have to reduce. Okay. Otherwise, it will cut whatever backup plate we have. That will cut. No, you have to arrange a system at the bottom of your workpiece so as to reduce the energy, residual energy. We call it as residual energy with the jet. Okay, that's all about abrasive water jet. Okay. எங்க இருக்கீங்களா? ஹலோ ஹலோ. இல்ல இப்போ டைம் ரொம்ப ஆயிட்டு இருக்கே, என்ன பண்ணலாம்? ப்ரொசீட் எப்படி பண்றது எனக்கு தெரியல.
எவ்வளவு ஸ்லைட் இருக்கு?
இது போது இப்பதான் 92 போயிருக்கு. It will go up to 140 slides இருக்கு. So otherwise I will do one thing. I will just I will just other two process I will just explain the principle. Then we will move on to the discussion session, right?
Metal removal எப்படின்னு மட்டும் சொல்லிட்டு finish பண்ணு.
Mechanical, whatever we discussed so far, the material mechanism, removal mechanism is mechanic impact erosion as well as microchipping. Those two is common for all. Okay, but only advantage what we have in abrasive water jet, whatever abrasive particle and debris that will be carried away from the work area. The working area is clean because the jet is continuously interacting with water jet is continuously interacting with the workpiece, that will be removed away, right? In other case it is not so. The mechanism in all the mechanical energy based process is impact erosion and micro cutting. Okay, this micro cutting or micro chipping, different names they call. You try to understand all mechanical process, you will be having impact erosion. Most of the questions they may ask, no multi choice question, no they put this. Okay, right. I will not read everything. I will just skip this. Okay, now we will come to laser beam machining. See, I cannot cover the entire physics behind the laser beam, but I hope you all know laser. No, laser is nothing but light amplification by simulated emission of radiation. I hope everybody studied in physics light amplification by stimulated emission of radiation. 4 terms you have to remember. One is spontaneous emission, right? Spontaneous, before that you have to absorption. There is a phenomena called absorption, emission, and this is stimulated. Third phenomena, this is first and this is second and this is third. Okay, simulated emission, this is how is very important. And another one is population inversion. Okay, you just go through your physics book, try to understand this three. Okay, if you want to understand the basics of laser, then you have to understand absorption, spontaneous emission, simulated emission, population. I will just show you some figure. Yeah, I have it. Yeah, see you, I hope I will just take something here. Yeah, see here, you have to you are already studied, right? In physics you have nucleus surrounded by K, L, M and shells. This you studied, right? You just consider two levels, one is low level and high level. Okay, there is a atom here, one photon is coming and it hits here. Okay, so if it light, if you supply light, right, light is nothing but a photon, right? So the photon comes and hits here, so it will be excited to the higher level. Okay, to the higher level. What happens? This is a metastable state. It cannot stay for a longer period. It will only stay up to 10 power minus milliseconds. Okay, it's milliseconds only. So after that, it cannot stay there, or it should come out. It should come to the stable state. Okay, like how you initially you will take iron from iron oxide, and later it will undergo rusting process. Again, it will go to iron oxide. Okay, how rusting takes place? You just do a Google search, understand. Similar to that, it is not a metastable state, so it should come. When it comes down, this is going up. No, that is called simultaneous absorption. When it comes down, it will release a photon. Okay, it will release a photon, that is called spontaneous emission. Okay, if you studied physics, you might have studied, but just to refresh it, some incident photon will come and hit here. This photon will be excited to the higher state at higher level, and it cannot stay there for longer period. It has to come down to the lower state. When it comes down, it will release a photon. Okay, this is called spontaneous emission. Okay, right. Suppose before coming to the lower level, another photon will come and it hits here. Already this no spontaneous emission, because of the spontaneous emission, you will have one photon. Okay, when it hits, it will release another photon. Like, this is called stimulated emission. Simulated emission means something from the no at the top level is there. If it comes automatically, then it is called spontaneous. When some photon come and hit no the atom at the top level, no, if it hits that, then if it release some photon, then it is called uh, simulated emission. That is what you are seeing here in this simulation. What you are able to see here, are you able to see the animations? Yeah, likewise, no, you just see many number of excitation is there. You will have this, right? You just go through it. The mechanism I will just tell you. You have flash tube. Okay, just to know create photons, and you have a ruby crystal. Many types of lasers are there. Solid laser, no, gas laser, and some semiconductor laser also available. Solid laser is very popular, and solid laser is ruby is very popular. Ruby crystal. I hope this you studied in physics. Flash tube, xenon flash tube, and all you studied already. Okay, so lot of excitation will be there, and you one side you have a partially reflected mirror, other side you have a totally reflected mirror. When you just flashlight is switched on, these all excited photons, it will move back and forth. Okay, this side if it goes, it cannot go through because it is completely totally reflected mirror, so it has to come out. Okay, so when it come back, it goes hit there and come back, it follows a single path, like whatever you are seeing here, it is going this way, right? This is called collimated source. Collimated in the sense all will follow in a single path. Okay, same, it is not going like this. When you switch on the light can no diffract anywhere like this. That is the difference between laser and normal light source. Laser light source, this is your bulb, whatever light bulb what you are using in your home. It all the photon, no, there is no control over the direction. But in the laser, you have a collimated source. Okay, it follows in a single path. That is what you are seeing here. It will go through the partially reflected mirror, and it will come out, and it will be used as a heat source. Okay, that is three things you have to understand. One is monochromatic. What is meant by monochromatic? Wavelength. Wavelength is this, right? One thing, right? This distance, right? This is one. Okay, lambda, we call it as lambda equal to one. Wavelength is one, means monochromatic, right? And coherent. What is coherent? You see the bulb, the direction, everywhere it is going, right? Laser, you see, all are collimated source. Okay.
ஏகேஎல் உங்க ஆடியோ வரல. ஏகேஎல் உங்க ஆடியோ வரல.
Somebody muted me. Is it now audible?
Yeah,
Hello.
okay.
A muting problem
okay.
is there. Yeah. No problem. Okay. I'll see. I told you 7 important parameters or the terminology. Number 1 is the absorption and spontaneous emission, simulated emission, and popular emission. Just go through it. I have not covered that. And monochromatic, coherent, and collimated. Okay, these are the things. You see the laser source and the bulb, because of the diverging and goes everywhere. Point uncollimated. Okay, this is collimated source. Okay, this is diverging light. Okay, different. This is laser. Okay, this is your laser. You see coherent. This is coherent. You see peaks, they are coherent. Okay, they are not coherent here. Peaks and valleys are not matching. This is your amplifying medium. Amplifying medium is the ruby crystal. Okay, ruby crystal is your amplifying medium. Some energy input is called xenon. Okay, xenon light source, that is flash tube. This is, I hope you all studied. That output is being used in our case here. You have a lasing material, flashlight, mirror, everything is there. This you already studied. That will be attached. Your workpiece is attached to your CNC control. The mechanism I will tell you. You have a workpiece. If a laser source will come, see these laser, they are not diverged source. I hope Professor, sorry, wait a minute. I will just some problem with my pointer. Wait. I'll just take it. In the welding, if you see, you have a diverged heat source. Suppose if you want to do gas welding, take a gas flame and just touches the workpiece. It will spread like this. But in case of laser, it is a concentrated source. Okay, it's not a diverged source. It's a concentrated source, and it will be converging, right? Your laser source is a converged source. So whatever the penetration, it will be very smaller area, right? So what happens? Your laser source will come. What happens? It will melt a particular material because of the energy density. Energy density means the energy per unit area, per unit length, per unit area. Suppose how much area, what is the energy you are supplying? Okay, that is very high for laser. It comes around 10 power 7 watts per centimeter square. Okay, 10 power 5 to 10 power 7 watts per centimeter square. So it will melt this material and it will also evaporate this material, vaporize this material. So any thermal based processes, laser or electron beam or plasma beam, all this process, your mechanism of material removal is melting and vaporization. Okay, so that is the primary mechanism in all thermal based process. Whether it is electron beam, whether it is a plasma beam, only the source, heat source is different. Okay, you see here, first your laser beam, the photons, they will come and touch your workpiece. There will be absorption of the photon by the material, and that causes heating. Some conduction will also there, and because of the heating, there will be melting takes place. Okay, because of the heating, melting will takes place. This is your liquid, and this is your solid, and there will be some solid liquid interface. Okay, what happens after some time? Your focus beam is focused this area, and whatever material melted, which will be evaporated, and it will be evaporated this way. Okay, and this keep on goes. First, your laser, because your heat source, it is not continuous. It is called pulsed laser. Okay, pulsed laser. They will supply laser source. They will melt it. Once your melting is over, at that moment there will not be any laser source here. Only the gas will be purged to just vaporized. So it will vaporize for some time. It will be vaporized because there will be some gap. If you do pulsing, there will be some gap. Okay, pulsing will go like this. There will be on and off like that. It will go. So melting and during At the peak, melting will be there. It will come down. Evaporation will be there. Again peak, evaporation, and it will go like this. This is called keyhole process. Very useful for very small holes like 0.2 to 0.005 mm. Very small holes, okay? That is not at all possible by drilling process, okay? And especially if you want to do perforation, I hope you studied about perforation, small holes in sheets. If you do that, if you want to do this, very small holes, it is not possible by conventional machining process. It is possible by laser electron beam, right? Okay. Last thing is Faraday's, electrochemical. Here the main mechanism is dissolution of metal. Please understand the main mechanism is dissolution of metal, okay? Here the chemical reaction and dissolution. This is how wherever the grinding is not possible, especially with a physical kind of grinding wheel, is not feasible, where your material this ECM is useful, okay? Faraday's law, you just go through it, mass of dissolution. I hope you all studied in physics and you did some experiment, electroplating, okay? You will be having two plates, and other one is cathode. Okay, I hope this is negative. Understand this. You just connect these two. What happens? There will be loss of material, anode from, and it will be deposited to your cathode, right? This is the actual happens. But in case of ECM, this fluid here is stationary. Okay. What happens in ECM? This fluid, continuously they will circulate. Okay. So before depositing to the the cathode, what happens? Anode is getting diluted in the cathode. That is what actually it is called electroplating. Okay. But it is reverse. It will not coat, but it will remove material, and while it removes, this fluid will carry away the fluid, right? This carry over the whatever material removed, that will not be deposited in your workpiece. There are some pure mechanism in that, you just don't worry about it. Your cathode is there, your anode is there, some kind of reaction will take place. See here, this is your iron, okay? This is your iron. The dissolution, there will be some reaction based on your electrolyte. There will be some debris. This is your final debris. Some loss of material here, that will be carried, pressurized or flushed. Okay, this will be flushed by a fluid. Okay, it will go and it will go away, right? This is the actual setup. You have a pump, filter, just to supply electrolyte. It will go through this insulation and it will just have this contact at the top surface. You have contact, it will have reaction, and it is continuously, it is supplied. Whatever debris which is coming, it is flushed away. It will be collected to the tank. Again, it will go to it will go to this tank. Again, filter, it is circulated. Okay. So primary mechanism is dissolution of. Please go through the term electroplating. Okay, that you already studied, right? Electroplating. Before deposition, it will be removed from the anode. That is the about ECM. I stop here because I am running out of time. I stop here. If you have anything to ask, I'll be happy. I will share this slide with the professor Dr. Balakrishnan, and he will share it to you. Okay, you can go through it. Still, address is with the professor. You just get it from him. You can mail me, right? If you have any doubt, I'll be happy to clarify now, or otherwise we will just close this session. Thank you very much.
Thank you very much, Professor AKL. Actually, it's very exhaustive presentation. And yes, as I told you, really interesting topic. I know that it take me interesting topic. I know that it take me much time, but you feel that I will complete within 1.5 hours. That is the reason why I was surprised yesterday. No problem. The thing is, our students' capacity is really adaptable to you. The thing is, they are a little hesitant to post question. Actually, if they are interacting with you, then definitely you will be getting some. Why didn't they post questions? So the kind of attitude with them is little difficult to manage. They really hesitant to ask questions. But if we give the opportunity, then they will post many questions. Disappointment of not
No issue, no. See,
writing much.
I'm handling on both kind of, both sides, right? So it's
Yes,
not
yes.
an issue. It's not an
Yeah.
issue, but you
Please.
can just, just collect your no questions. If not possible now, just collect your question. Just post it to me. Uh,
Yes,
I,
yes,
I will share my answers. Yeah.
definitely, definitely. Thing is, when I was surprised because these second year students I didn't meet even in a single person. When I was
Yeah.
having a chance with interact with them through their presentation day, I really surprised because of their presentation. So that is the reason
Okay.
why I give some promising
No,
questions they
no.
could have asked, but I don't know
Not
why they
even
didn't ask.
even for us, it's a starting problem. Once somebody started asking, then everybody will come and ask. There is
Mhm.
a starting trouble actually. This is might be I will come again, no, in the next semester
Yeah,
for
yeah,
some other
in some other day,
subject.
definitely.
Yeah,
Once
yeah,
once you just meet them, definitely you'll be getting surprised because they are really good enough to ask questions. Not only ask questions, suggestions, feedbacks, everything. But the thing is,
yeah,
they are not yet coming to the department. It's the strength of each faculty. That may be the reason they are little hesitant to ask questions.
no
But
issue, no.
definitely, some of them may have some questions. May I
Yeah, yeah.
expect any questions from you, friends? My dear friends, any questions you have? Please post.
Sir, good afternoon, sir.
Yes,
Yeah,
sir,
go ahead,
please.
please.
Yeah. So, in abrasive jet machining process can be used only in conductor or insulator or both, sir?
See, here abrasive, no, see, its workpiece is no, it's not in the circuit itself, right? You can
Okay,
do
sir.
any material, right? Any material, right? Just you have interaction, that's all. Whether it's a conductive or non-conductive, it will not affect the performance, right? Because we don't have any power supply to that material. But in case of ECM, you have to have conductive materials. That is a drawback of that process.
Okay, sir.
ECM
Sir,
and
in
one,
what?
yeah,
Yeah,
please.
yeah. Tell me, sir. Tell me, sir. You finish.
Yeah. The problem is, in case of VDM also, it should be conductive. That is a problem. Uh, See, in case of abrasive, it is a pure mechanical action. Okay, there
Okay,
is no
sir.
problem of conductivity, right? There is no problem of conductivity there. Irrespective of conductivity, you can machine, right? It is advantage of that. Even that I told you, glass you can machine.
Okay, sir. Sir, in water jet machining have only used for light material and abrasive jet material only used for heavy material. Is it possible to water? Yeah, I think. Sorry, machining, jet machining and I think another one jet machining. Any possibilities for either two in one, sir? In abrasive jet machining.
See, water jet, you can generate pressure. Initially, it was developed actually. See, if they, it is not meant for cutting materials. Okay, it is not meant for
Okay.
metals. Actually, water jet, actually, it
Yeah.
was developed to cut woods. Okay, wood material. Okay, the process
Yes,
was
sir.
developed for wood material. Later, they just combined abrasive, and now it is very popular. Abrasive jet machining is popular. You can use either soft metal, hard metal, or thin material, thick material. Both you can use abrasive water jet itself. The only problem is the machine is costly.
It's costly. Comparing with the abrasive
Yeah,
jet
water
machining.
jet, abrasive. No, abrasive jet is not so difficult. If you have a compressor, no, it's very cheap. You can fabricate in your lab itself. Abrasive jet not
Yes.
easy. It's not difficult because water jet you have hydraulic power pack, you have intensifier, you have accumulator, everything you have to fabricate. But in case of abrasive jet, only you need a compressor. That's all, air compressor and some no some tubes and some nozzle. That's all. Nothing else.
Okay, sir.
Abrasive jet is easy. Okay, abrasive
Okay,
jet
sir.
is not so difficult. Water jet and abrasive water jet is difficult because you have to control the pressure of the fluid.
Okay, sir. Okay, sir. Sir, I saw the abrasive jet material, abrasives like materials like olivine. What is meant by olivine, sir? I saw your presentation slide.
No, olivine is one of the particles. Right, is one of the ceramic particle. No,
Okay,
it is
sir.
used for. That is one of the particle like garnet, silicon carbide, boron carbide, like several particles. This is one of the hard particle. Okay, naturally available particles.
Okay, sir. Okay, sir. Okay, sir. Thank you so much, sir. Have a nice. Yeah.
Even
Nice
sand,
presentation,
no?
sir.
Yeah, thank you, thank you. Okay. Yeah,
Yes, sir.
yeah,
Sir,
yeah, yeah. Please
sir,
go ahead. Please go ahead.
sir, and the abrasive grains எல்லாமே brittle material தானே sir?
See, they are hard, but they have sharp edges.
Yes, sir.
Yes, it is brittle. It is brittle. It is brittle. It will break.
Sir,
But
அப்ப
it is
break
so, it is so hard. See, what we have a workpiece. Your abrasive is harder than your workpiece.
Yes, sir.
That means it will not, even it is brittle. When it interacts with a softer metal, it will not fail. No, your workpiece will fail.
Yes, sir.
That means you need, there is no problem, right? You need a brittle material. You need hard metal. That's all.
Yes, sir.
It
Okay,
will,
sir.
only the edges, they will break. Once if remove material, the edges may break.
Yes, sir. இப்போ
Okay?
brittle சார் brittle மெட்டீரியல்ல இருக்க ஒரு எட்ஜ் உடைஞ்சா இன்னொரு ஷார்ப் எட்ஜ் உருவாகும்ல சார்?
அதுதான் சொன்னேன்ல, நீங்க அந்த மாதிரி இப்ப இந்த ஒரு கேள்வி வரும்னு கண்டிப்பா எனக்கு தெரியும். ஒர்க் பீஸ்ல போய் ஒரு இடம் தானே படும்னு நினைப்பீங்க. இது ஒன்லி ஒன் சர்ஃபேஸ் வில் நாட் ஹீட். ஒன்லி மெக்கானிசம் படிக்கிறது தான் நம்ம அப்படி புரிஞ்சுக்கிறோம்.
Yes, sir.
ஒரு நிறைய எட்ஜஸ் படும், ஒர்க் பீஸ் மேல நிறைய எட்ஜஸ் படும். இன்னொன்னு என்னன்னா, ஒரு பார்ட்டிகல் இன்னொரு அந்த லைன்ல வருது இல்லையா, பைப் லைன்ல வரும்போது ஒரு பார்ட்டிகல் இன்னொரு பார்ட்டிகல் நிறைய இடத்துல மோதிக்கிறதுக்கு வாய்ப்பு இருக்குல்ல.
Yes, sir.
அங்கேயே சில நேரத்துல இது போயிடும். அதுதான் வந்து லாஸ் ஆஃப் மொமெண்டம் சொல்லுவாங்க. அதுக்கு தான் எவ்வளவு அப்ரேசிவ் கலக்கணுங்கிறது ஒரு ட்ரையல் அண்ட் எரர்ல யூ ஹேவ் டு ஃபிக்ஸ்.
Yes,
இஃப்
sir.
யூ ஆட் மோர் அப்ரேசிவ் ஆல்சோ யூ வில் எண்ட் அப் வித் ப்ராப்ளம். கம்மியா பண்ணாலும் மெட்டீரியல் ரிமூவல் கம்மியா இருக்கும். ஸோ அதை வந்து ப்ராப்பரா யூ ஹேவ் டு டேக் சம் ட்ரையல் அண்ட் யூ ஹேவ் டு மிக்ஸ் இட்.
Yes, sir. Thank you, sir.
மணிகண்டராஜன், நீங்க இன்னும் கொஸ்டினை கம்ப்ளீட் பண்ண மாதிரியே தெரியலையே. உங்களோட டவுட் என்ன?
சார் அதான் சார், இப்போ வந்து ஒரு கிரெயின் வந்து உடஞ்சிருச்சுன்னா அதை ரீயூஸ் பண்ண முடியாது அப்படின்னு சொன்னாங்கல்ல சார். சார்
உடஞ்சிருச்சுன்னு சொல்லலப்பா. அவரு தெளிவா சொன்னாரு. அந்த ஷார்ப் எட்ஜஸ் பிளெண்ட் ஆயிடுச்சுன்னா உடையும் பொழுது, நீங்க சொல்றது போல உடையும் பொழுது இன்னொரு ஷார்ப் எட்ஜ் தான் கிடைக்கும்.
எஸ் சார்.
உடையும் போது இன்னொரு ஷார்ப் எட்ஜ் தான் கிடைக்கும். பட் அந்த ஷார்ப் எட்ஜ் பிளெண்ட் ஆச்சுன்னா தான் இட் கேன் நாட் பி ரீயூசபிள்னு சொன்னார் சார்.
எஸ் சார். சார்
பிளண்ட்ங்கிறதுப்பா மழை ஆயிடும். இப்போ ஷார்ப்பா இருக்கிறது வந்து கத்தி இருக்கு, வெட்டிக்கிட்டே இருக்கீங்க, என்ன ஆகுது? மழை ஆகுது இல்லையா, அங்க வந்து உடஞ்சி போறதுல. அந்த மாதிரி மழை ஆயிடுறதுக்கு பேர் தான் பிளண்டிங். பிளண்டிங்னா இட்ஸ் நாட் அ ஷார்ப் சர்ஃபேஸ், இட் இஸ் அ ஸ்மூத் சர்ஃபேஸ்.
எஸ் சார்.
அவ்வளவுதான். உடையறதுனால இன்னொரு பிரிட்டில்னஸ்னால உடையறதுனால இன்னொரு ஷார்ப் எட்ஜ் தான் கிரியேட் ஆகும். ஆனா பட் தேர் வில் பி அனதர் ஒன் கொஸ்டின் நீங்க கேட்கலாம் சார். பெரிய சைஸ் பார்ட்டிகளா இருக்கிறது சின்ன சைஸ் பார்ட்டிகளா ரெண்டு உடையும் பொழுது அப்ப அதனோட மெஷினபிலிட்டி எப்படி இருக்கும்னா அதுக்கு ஒரு கிராஃப் போட்டிருந்தாரு. பார்ட்டிகளோட சைஸ் சிறுசாக மெட்டீரியல் ரிமூவல் ரேட் கம்மி ஆயிரும்னு ஒரு கிராஃப்ல போட்டிருந்தாரு. நீ அதுல அந்த கிராஃப் எல்லாம் அதுதான் இன்ஃபரன்ஸ் பார்க்கணும் நீங்க. ஓகே, வெரி குட் கொஸ்டின். 2 கொஸ்டின் அருமையான கொஸ்டின் வந்திருக்கு. வேற யாராவது டவுட் இருக்கா? வேற ஏதாவது டவுட் இருக்கா சாமி? அண்ணா வேற ஏதாவது டவுட் இருக்கா இல்ல வைண்ட் அப் பண்ணிக்கலாமா, க்ளோஸ் பண்ணிக்கலாமா? 2 கொஸ்டின்ங்கிறது இது அவ்வளவுதான், ஏற்புடையதல்ல.
Okay, they little bit hesitated. Just write, okay, you just post a question. I used to do in my class, I used to share Google Sheet. Okay, they will put their question there. I will just try to answer for them in the class itself. Okay, leave it. That's not a problem. We'll meet again some other day. We'll discuss some other topic, right? Okay.
Okay, if no more questions, we will wind up this session. I personally thank you very much for your nice presentation, Dr. A.K. Lakshminarayanan. And I, on behalf of the Department of Mechanical Engineering, M. Kumarasamy College of Engineering, also I wish to register my sincere thanks to Dr. A.K.L. Actually, I called him 2 days before only. So Wednesday only I called him. Wednesday or Thursday I called him, and immediately he accepted. I know he's really busy with his academic and personal activities, but only because of many times he accepted, and not all the time he is not able to turn up to our institution. That is the only chance we had. And Corona is actually good for us because it makes many people to get into our institution without a single paisa, and also various parts of the world. So in that way, Corona do some favors for our student community and faculty community. Thank you, Corona, and thank you, AKL. Thank you very much.
Corona and AKL are not same.
No, I'm not meaning that Corona only AKL has said. AKL is really, honestly saying, he is more serious than Corona. I know him very well. Okay, let us talk
Okay,
personally.
okay,
Thank you very much, AKL. Thank you.
okay. Thank you for the opportunity. Thank you. Okay, I'm first time I'm interacting with the different college students. Okay,
Thank you.
thank you very much. Okay, bye. Okay.
Students, please wait for some time. Now AKL will leave and we will discuss maybe 5 minutes. தம்பிகளா, இது எனக்கு என்னமோ சரியா படலையாப்பா. நீங்க என்ன கொஸ்டினே கேட்காம இருக்கிறது?